chlorine, some sort of a sealant on all of your walls in the basements to keep the gas from leaking in from outside. All right. You guys ever heard of radon? He's the only one that's heard of it, right? It's the radon poison, that radon gas. All right. Radioactive. See, it's got the parentheses here, right? Or it's got the little dagger symbol if you want to look over here. It's a radioactive gas. Wow. Any other questions? So you think that's neat? Yes, no? Right. And I know some of you guys are sitting here thinking, man, can you imagine the lead aprons, the lead panties, right? And by the way, that's wore on, they call them lead panties, but it's actually wore on the outside of your clothes, so there is no, you know, dirty type pictures, if you will, there. Anybody got anything else, any other questions? No? Wonderful. All right, well, you guys have probably had some sort of an apron put on you for shielding if you've had an x-ray, right? All right, well, you know how heavy that is. Well, the ones that chemists use are actually made of the pure metal. They're not flexible. So it is actually like putting a sheet of metal on you. I mean, like when you squat, it don't bend. You know what I mean? I mean, it just goes straight out like this. And no one likes that drama. Okay, so we're into chapter 3 talking about this periodic table thing. All right. Now, the next thing is what? Are we talking about? My mind just went blank. I know. We start connecting them together. Okay, and this is the atom count. So, for example, if we've got potassium chloride there, which this lady just held up for us, that's KCl. That means 1 potassium, 1 chlorine. How did I know that? Well, I know capital C and lowercase l is chlorine. That is a single atom. And I know potassium is a single atom when I do this notation. So how many total atoms do we have here? 2. All right. Now, if we look at something here like aluminum sulfide, and again, you do not need to know at this point until chapter 6 how to give birth to Al2S3. What we're looking at now is doing an atom count. How many atoms of aluminum do we have? 2. And how about sulfur? 3. All right. So that means the total of 5 atoms inside this compound. Now, I just want to say sometimes chemists use the word compound and molecule interchangeably. They're wrong by doing that, but sometimes we do it. And a molecule technically is a substance that is bonded covalently, okay? Or a compound is something that is bonded ionically. But sometimes we get sloppy. The same way with weight and mass. What's the difference in weight and mass? Anybody know?
Something, weight is how heavy it is, and mass is how large it is.
Mass is just a single number, okay, such as 140 pounds if you weigh 140 pounds, such as 28 grams. Those are all masses. But a weight is something that is generally measured in newtons and has a direction. So in other words, you take the mass times the acceleration of gravity, and that's what a weight is. Now, nobody in their right mind in chemistry pays that strict of attention. So if I tell you, hey, go get the weight, and I'm in the chemistry lab, what I mean is go get me the mass of that. All right. Now, physicists are very particular about this mass and weight thing, all right, because weight is actually a vector quantity. It's multiplied by the acceleration of the gravity and all this, okay? Well, same way when we talk about molecules and compounds, okay? A molecule strictly is just a covalently bonded thing. Now, let's look at something like aluminum sulfate. Now, aluminum sulfate looks like this. Again, don't know how to give birth to it, but here's what we got. How many atoms of aluminum do we have? 2. Now how about here, sulfur? Well, there's 1 there, right? But this parentheses means that you have to take 3 times 1. So that means 3 atoms of sulfur. Okay, how about here, how many atoms of oxygen? So we've got 2 plus 3 plus 12 for a total of what? 17? Is that good? Okay, nobody said anything, so I'm sitting here counting on my fingers like I'm in second grade. All right. So that's how that works there. Okay, does anybody have any problems?
Where did you get the 2 atoms from aluminum?
Right here, there's a little 2 right there.
I mean, do you see that, is that on the periodic table? Or?
Nope. When you're asking these questions in this chapter that we're talking about right now, this whole thing has to be given to you.
Okay.
All right?
The
Yeah.
three on the outside, is that just like something extra that you'll learn later, or is that like actually part of the SO4?
It's not part of the SO4. It's actually part of the aluminum. But yes, we will learn it later. All right? Those are Chapter 6 questions. They're good questions, Chapter 6 questions. Which I've always thought why this book goes into this right now, but whatever it does. So we're going to talk about it, all right? I always prefer to really talk about it in Chapter 6 because that's where you need to be talking about it, all right? But whatever. All right, are we good? Okay, so let's go in our textbook, if I can find mine. And let's see if we can just, on the cuff, answer a couple of these random Chapter 3 questions. All right. Here we go. Let's try 29E. All right, 29E, and this is on page 64. I'll write it up for you. It says, okay, I want to know how many total atoms are present in this compound right here. This is called calcium nitrate. Okay, and I want to know how many total atoms are present.
8, 9.
Okay, she says 8. Let's count them up. How many calciums are there? 1. How many nitrogen are there? 2. And how many oxygens are there? 7, 8, 9. It's a total of 9. All right. Let's try one more there. Let's try iron 2 phosphate. Okay. So iron 2 phosphate looks like this. And you guys will be able to name these and you know, there is a method, by the way. I mean, these numbers are not just pulled out of your nose. There are places this comes from. It's just we're not ready for it yet. And this is called iron 2 phosphate. How many total atoms have we got? Okay, somebody's saying 13. I know for iron we got 3. For phosphorus we got 2. And for oxygen we got 12. So it's 12, 13, 14, 15, 16, 17.
Should be 8.
Oh, yeah, that's right. Now, I'm testing you guys, right? Oxygen is 8. All right, 8, 9, 10 plus that is 13. So now I see where you get your 13 from, right? I have no idea what I was thinking. Okay. So, are we good with that type of question? Okay, let's do some more then. Let's see here what we got going on here. Now, okay, number 30 sounds good, and then we're going to do number 38. So number 30, we're talking about vitamin B12, which I know a lot of you guys have heard of, and its claim to fame is energy, right? Anybody, my mother loves these B12 shot things. I guess they work, I don't know, I never have had one. But here's what it looks like. C63, hydrogen 88, cobalt, nitrogen 14, oxygen 14, phosphorus. This is number 30. I'm on page 64. Now this is a neat little compound. What's the trouble? What's so funny? Oh yeah, it's a lot of numbers, right? I mean, certainly it's a big vitamin. It's one of the B vitamins. It's water soluble.